So you're an engineering student, and you're fascinated by those tiny little chips that literally power our entire world. But you've probably asked yourself, how do I get from my classroom to actually designing them? Well, think of this as your personal roadmap, a clear step-by-step guide to building an amazing career in VLSI.
We're going to break this whole journey down into 6 key stages. We'll kick things off with the absolute fundamentals, then we'll move into specializing and getting your hands dirty with projects. After that, we'll talk about getting real industry experience, building up your toolkit, and finally, launching your career.
All right, let's start with the big picture. Before we get into all the specific courses and tools, it's really important to get a feel for what we're talking about, both the challenge and, the massive opportunity that a career in VLSI really is.
This is the big question, right? It's one thing to hear the term VLSI thrown around, but how do you actually become one of the engineers creating these incredible pieces of technology? Let's break down that path.
So, what is VLSI really? At its heart, very large-scale integration is all about the magic of packing millions, and today, even billions of tiny switches called transistors onto a single tiny chip. This is the tech that makes everything possible, from the phone in your pocket to the powerful computers in data centers.
Your journey really begins by building a rock-solid foundation. These first couple of years, they're not just about passing exams. They're about truly deeply understanding the principles that every single part of chip design is built on.
Your first 4 semesters are absolutely packed with the essentials. You're going to start with the basics, right? Electronics, C programming, and math. From there, you'll dive into the real heart of it all with things like digital logic and semiconductor devices, and it all leads up to cornerstone courses like CMOS VLSI Design. You can see how each semester just builds right on top of the last one.
Now, the crucial thing here is to go way beyond just the theory. You have to master these skills. I mean, Boolean algebra, that's the basic language of all digital logic. Things like gates and flip-flops, they're like the Lego bricks for everything you're going to build. And getting good at a hardware description language or HDL like Verilog, well, that's completely non-negotiable. It's how you'll tell the software what you want to create. Okay, your third year is where things get really exciting. You're going to shift from just learning the fundamentals to actually applying them, digging into key areas, and most importantly, you'll start building real projects. So in semesters 5 and 6, your coursework gets deep. You'll be tackling advanced topics like analog circuit design, system on chip, we call that SoC, and a huge one, VLSI verification. It's right around here that you'll start to see the different career paths within the industry really start to take shape.
And get this, here's a reality of chip design that might blow your mind. A whopping 70%. 70 of the entire design cycle is spent just on verification. That's all about testing and making absolutely sure the chip does exactly what it's supposed to do with 0 bugs. This makes verification one of the most critical and, honestly, most in-demand skills you can have.
All right, now it's time to get your hands dirty. Building projects like an 8-bit ALU or a traffic light controller, that's how you show you really get digital logic. And implementing protocols like SPI or UART proves you can work with real-world specifications. These are the kinds of projects that are going to become the heart and soul of your portfolio.
Your final year, this is all about bridging that gap between college and the professional world. The focus totally shifts to getting real industry experience, usually through a major internship, and getting you ready for job placement.
And just look at the kind of opportunities available. In major semiconductor hubs like Noida, you've got top-tier companies like STMicroelectronics and NXP offering long-term, paid internships. And look, these aren't just summer jobs to get coffee. They are deep-dive experiences that very often lead directly to a full-time job offer right after you graduate.
But landing one of these roles is a pretty rigorous process. As this quote from Synopsys shows, it's a multi-stage thing. You should expect a resume screen, probably a phone interview, and then some really deep technical interviews where all your fundamental knowledge and those projects you built are going to be put to the test.
Okay, so you have the academic knowledge, you've got project experience. Now, to be a really successful engineer, you need to master the tools of the trade. Let's take a look at the essential toolkit you need to start building right now.
Your toolkit really breaks down into 3 key parts. First, you've got to master the languages. And I don't just mean Verilog for design, but also System Verilog for verification, and scripting languages like Python for automating tasks. Second, you have to learn the software, the electronic design automation, or EDA tools. And third, never stop learning. Use online platforms to stay ahead of the curve.
Now the best part is, you don't need expensive corporate licenses to get started. The open source community has some incredibly powerful, totally free tools that cover the entire chip design flow. For example, OpenLane gives you a full path from your written design, that's your RTL, all the way to the final GDSIL file, which is basically the master blueprint you'd send to a factory. And you can do it using Google's Sky 130 PDK, which is like the rulebook for a real manufacturing process. You can design a real chip right on your own computer. How cool is that?
And to really deepen your knowledge, these resources are just gold. NPTL, for instance, has full-on university-level courses taught by top professors, a lot of them with industry support. And for hands-on coding practice, a site like HDL Bits is an absolutely fantastic way to sharpen your Verilog skills by solving real problems.
All right, you've followed the roadmap. You've built the foundation, you've done the projects, you've mastered the tools, and you've gotten some real industry experience. Now for the final, and let's be honest, the most exciting step, launching your career.
As you step into this profession, it's really worth remembering that the digital systems you're going to create, they're not just abstract circuits on a screen. They are going to shape the future of communication, of medicine, of our entire society. It's a field with incredible power, and with that comes a pretty profound responsibility.
The pace of innovation in this field is only getting faster. I mean, the challenges and the opportunities of the next decade are going to blow away anything we've seen before. You now have the roadmap. You have the tools to be a part of it. So the only real question left is, what will you build?